Welcome back to the Math Professors. Our YouTube channel covers topics that can be found in any college math class. Today what I want to do is I want to graph trigonometric functions using transformations as opposed to just using symmetries that they usually teach. So this is kind of an interesting way to graph trig functions. So remember if I want to graph like y or f of x is equal to the square root of x, I know that its parent function looks like this. This is just a square root function. And what I want to now graph is y is equal to negative the square root of the quantity 2x minus 1 plus 5. And I want to see what these transformations do to this function. And then I'll kind of verify it because I know the point has a solution point of 4 comma 2. And I want to see what happens to that point. And when I plug it in here, it's going to really make sure that new solution point is a solution of this. So let's talk about the transformations. Let's start out with the x coordinates. Now, the x values are done by, what's inside the radical. So, these are where the x's are manipulated. So, the way we do the x's is we essentially have to just solve for x. So, what I know is this is going to take it, I'm going to have to add 1, so it's going to go right 1. And then I'm going to have to divide by 2, which means that this is going to be a horizontal compression of 2. Now the y values, what's going to handle the y values is going to be this negative sign and this 5, and what we do is for y values it is evaluation, so you have to do the multiplication before you do the addition. So this negative is going to flip it over the x-axis, and then finally this 5 is going to make it go up 5. So let's do this in order. So I'm going to actually do the progression of this. And then this will finally be my solution. So the first things first, that this thing has to go right 1 unit. So right 1 unit. So it's going to go over here. So that is this function here. And what that is that would be y is equal to the square root of x minus 1. Now I have to horizontally squish this by a factor of 2. So when I squish this by a factor of 2, it's going to, squish a little bit. So it's going to squish the entire thing. Basically what it's going to do is going to take all the x's and divide by 2. So instead of this thing going through 1, when it squishes everything, this is now going to become a half. And then this is going to get compressed as well. But it's still going to have kind of that similar shape. So this is going to be y is equal to the square root of 2 times x minus 1. Now, what this does is going to flip it over the x-axis. So if I have y is equal to minus the square root of 2x minus 1, it's going to take that and flip it over the x-axis. So it's going to look like this. So this is going to be equal to half. And finally, when we have last point, this is going to have to go up 5. So here I have 1, 2, 3, 4, 5. So right here. And this is going to go up 5. So it's going to have something like this. So finally, well, that's this picture right here. Our solution finally is going to be y is equal to minus the square root of 2x minus 1 plus 5. So that's what we have. Our final solution looks like this. So what I know is that this is the point 1/2 comma 5. And we can, kind of verify that that is a solution of this thing. So let's just check. So 5 better be equal to minus 2 times the square root of 1/2 minus 1, plus 5. So when I simplify this, I will do inside the radical first, or the parentheses. So this is going to be 1 minus 1, which is the square root of 0. So negative the square root of 0. So minus the square root of 0 plus 5, which is going to be equal to 5. So we can see 5 is equal to 5. Let's also see what happens to the point 4 comma 2. When I go right 1, this is now going to become the point 5 comma 2. Now, this is going to squish all the x values in half, so half of 5 is going to be 5/2, so now it's going to be the point 5/2 comma 2. And then we're going to flip it over the x-axis, so it's going to change the sign of that y value, so this is going to be 5/2 negative 2. And then finally I have to go up 5, which is going to take that negative 2, it's going to add 5 to it, so this is now going to be 5/2 comma 3. And let's check to see if that works out. So plugging in 3 into, remember I'm plugging into this function, so 3 is going to be equal to negative the square root of 2 times 5 halves minus 1 plus 5, and see if that works out. So 3 is equal to negative the square root of, this is going to be, 5 minus 1, so 5. So this is going to be the square root of 4, so this is going to be minus 2 plus 5. So then we can see that, 3 is equal to 3. So this does work. All right, so that was just a refresher of transformations with a familiar function. Let's do this with trig functions. All right, so here's the function I want to graph. So I want to graph the trigonometric function using the parent function f of x is equal to the sine of x. So let's start out with, let's call this y. Let's start out with f of x is equal to the sine of x. So f of x is, well, just look at the sine of x. If I want to graph the sine function, we really just look at the unit circle and we look at our, our 5 key points is what we call these things. Really the nice points. So this is going to be the point 0, 1. This is going to be, nice. This is the point 1, comma 0 over 1 up 0. This is the point 0, comma 1 over 0 up 1. This is negative 1, comma 0. And this is finally 0, comma negative 1. Now, what we know is the sine function is going to be the y-coordinate, and then we have to worry about the angles. So, this is angle 0, this is pi over 2, this is pi, 3 pi over 2, and then back to 2 pi. So what we know is we have, 5 key points. So our points are going to be 0, comma, remember that we're going to do the sine function, so we're using the y-coordinates. So angle 0, output 0. Next is going to be angle pi over 2, output 1. Then I'm going to have angle pi, output 0. And then angle 3 pi over 2, output negative 1. And then the last point is going to be, this is also 2 pi, comma 0. So these are our 5 key points. So what I know is the sine function is going to look like this. It's going to go through 0, comma 0. So this is 0. This is pi over 2. We have pi, 3 pi over 2, and then finally 2 pi. And let's say this is 1, and down here is going to be negative 1. So the first one's going to be, 0, comma 0, which is going to be right there. Then I have pi over 2, comma 1, which is going to be up here. And then pi 0, which is going to be back down here. 3 pi over 2, negative 1, and finally 2 pi, comma 0, and then we connect this with a smooth curve. Now we also know that that the sine function is periodic, so this curve is going to repeat in all directions. So if we want to continue, it's going to it's going to go in all directions. So a lot of times we just want to graph one period of this particular function, and that's good enough because I know it repeats. So let's graph a single period of this. But we have to talk about the transformations do. What does the 2 do to this function? What does the 3 do to this function? So let's take a look at the, the x values. Well, the x values are handled by, what manipulates x, which happens to be that 2 parts. So what I know, in order to solve for x, you're going to have to divide by 2. Remember, x's are handled through solving, and then y's are handled through evaluation. So we solve for x, so dividing by 2 means that this is a compression of 2. And then we have the y values. This 3, this is going to be the multiplication of 3, so this is going to be a vertical stretch of 3. So you're going to divide all the x's by 2, you're going to multiply all the y's by 3. So let's start here. So we know that this particular point, I'm going to have to, divide x by 2. So let's just do that to the x coordinates, because remember, this is only going to handle the x's, these will do the y's. So let's do the x's first. So 0 divided by 2, comma, we'll worry about the y's in a second. We're going to have pi divided by 2 divided by 2. We're going to have pi divided by 2. We're going to have 3 pi over 2 divided by 2. And then finally, we're going to have 2 pi divided by 2. And I know what's going to happen to the y's, so really remember we're compressing 2. Let's do the 2 in blue to see where that comes from. That comes from this 2 here. And then the y's, what I know I'm going to do is I'm going to multiply all the y's by 3. So let's use this 3 here. So let's multiply all the y's by 3. So I have 3 times 0. I'm going to have 3 times 1. We're going to have 3 times 0. 3 times negative 1. And then finally back to 3 times 0. And what does that do for us? So this gives us the new key points of our function is going to be, well, 0 divided by 2 is 0. 3 times 0 is 0, so that doesn't move. Pi over 2 divided by 2 is going to be pi over 4, comma 3. This is going to be pi over 2, comma 0. 3 pi over 4, comma negative 3. And this is going to be pi, comma 0. And let's graph it, see what happens here. And then I'll graph it over top of this and see truly what happens. So when I want to graph this, we know that our x values are going to go 0. We're going to have pi over 4. We're going to have pi over 2. We're going to have 3 pi over 4. And we're going to have pi. So then when I graph this, we're going to go with 3 to negative 3. So up 3, 1, 2, 3, down 3, 2, 3. So the first point is going to be 0, comma 0, which is here. Pi over 4, comma 3. Pi over 2, comma 0. 3 pi over 4, comma negative 3. Back to pi. So when I graph this single period with a smooth curve, this is what we get. Now if I drop this back on the original function, let's see what happens here. So I'm going to have to run into the other ones, but we have 2, and then we're going to have 3 up here, and then down to negative 2 and down to negative 3. And remember that we have pi over 4, pi over 2, 3 pi over 4, and pi. So our pi over 4 is right here. Our 3 pi over 4 is right here. Pi, what we can see is that this is 0, 0, up to 3, back down to 0, down to negative 3, back up to 0. So if I graph that function, get it in here, boom. What we can see is that this has been compressed by 2 and also stretched by 3. So that really kind of shows that compared to this, compared to this parent function. So let's graph one that's slightly more difficult. What I want to do is I want to also do a phase shift and also move this thing up and down as well. All right, here's our new function, but I'm also going to change the parent function. And instead of using the sine, I'm going to use the cosine. So let's kind of go back to that unit circle and talk about the 5 key points of the cosine. We're going to do exactly the same thing we did with the sine, but except we're going to use the x coordinates instead because that's what the cosine value is, or output. So what I know is that this is going to be the points angle 0, output 1, angle pi over 2, output 0, angle pi outputs negative 1, and then we're going to have 3 pi over 2 output 0, and then finally 2 pi, moving back all the way around the circle, is going to be 2 pi back to 1. So we're going to see what happens to those 5 key points for this function. So let's talk about the x values, we'll talk about the y values, and see what happens here. So x values. Now what manipulates the x values is what's going to be, inside the cosine function. That's going to be the angles are going to be your x values. So let's see what happens here. So in order to do the x values, we have to essentially solve this for x. Really what we're doing is we're solving for x 5 times. Like if I want to find the very first one, I set this thing equal to 0, and then I subtract pi, multiply by 2. And then I do it again. I'm going to set this equal to pi over 2. I'm going to subtract pi. I'm going to multiply by 2. So I'm just going to say what I'm going to do because the method of solving for x is the same every single time. So what I'm going to do is I'm going to subtract pi, and then I'm going to multiply by 2. So what this does is subtracting pi is going to move it this way, pi, and multiplying by 2 is going to stretch it. Now for the y values, That's going to be the operations outside the angle, so that's going to be, this -5 and also this 1. Now, with x's, you solve for x, that's why you have to, subtract and then multiply by 2, but the y values you evaluate. So if I had something like -5, like x minus 1, if I was going to plug a number in here, I have to multiply it by -5 first and then subtract 1 second. So that's why I'm going to do this operation first and this operation second. So let's kind of separate that -5. Well, the -5 is, let's do the negative first. So negative is going to flip over the x-axis. Now the multiplied by 5 is going to be a vertical stretch of 5. And then finally the subtract 1 is going to go down 1. So, and we'll talk about, about multiplying. So, this is multiply by a negative. This is multiply by 5, and then this is subtract 1. So that's going to be the operations we're going to do on the y coordinate. Okay, so I guess I should keep that. So let's start out with these 5 key points and work here. So first we have to subtract pi. So 0 minus pi, I'm just going to do the arithmetic. So 0 minus pi is going to be negative pi. Pi over 2 minus pi. So pi over 2 minus 2 pi over 2 is going to be minus pi over 2. Pi minus pi is going to become 0. 3 over 2 minus pi is going to become pi over 2. And then 2 pi minus pi is going to be pi. Now I have to multiply all the x's by 2 now. So multiplying by 2 is going to be minus 2 pi. Multiplying by that by 2 is going to be minus pi. This times 2 is still going to be 0. This times 2 is going to be equal to pi. And finally, pi times 2 is going to be equal to 2 pi. So we've taken care of both of those steps. Now, the y-coordinates are handled independently of the x-coordinates, so we might as well just do them in these rows so I don't have to write this 4 times. So, well, 5 times because I have an extra one. So we have to flip over the x-axis, which means I have to multiply by a negative. And I also have to multiply by 5, so let's just multiply it by -5 and do it at the same time. So if I multiply 1 by -5, this is going to be, -5. That's flipping it and stretching it. 0 times -5 is still 0. -1 times -5 is 5. 0 times 5 is 0, and then 1 times -5 is going to be -5. And then I have to go down 1, which means I have to subtract 1 to each one of these, so this is going to be -6, this is going to be -1, this is going to be 4, and this is going to be equal to -1, and then finally -6. So let's graph it. So what I'm going to do is just graph these points, and I can see that it goes from -2 to -2, so I have a symmetric interval, so I'm going to do my 5 key points over that symmetric interval. Symmetric means the same distance this way as this way. So this is going to be -2 pi, this is minus pi, we have 0, we have pi, we have 2 pi. Now, graphing it, we also have to go to -5 to +5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -5 and 5. So let's graph these. Oh, my bad. -6. 2 minus. Make sure. Yep. -6 to 4. I don't actually need that. I need -6 to 4. So I really just need the 4, and I need -6. Okay, so first we have 2 pi, -6, which is going to be down here. And then we're going to have -pi, -1, which is going to be right here. 0, comma 4, pi, comma -1, 2 pi, comma -6. And remember that this is a wave function, so it's going to look like this. So this is 1 period of this wave function. Now remember, it goes in both directions all the way, so it's going to continue in both directions and so on forever and ever and ever. Now, if we graph the original function, and let's kind of do this in pink. This is, pi over 2. This is pi. I don't usually ask you guys to graph the original function. I really just want you to graph the new function, but it's nice to see what actually happened here. So the cosine function goes, 1 pi over 2, negative 1, boom, 2 pi. That's these key points right here. So we can see this. So now we can actually make sure that this is true. I subtracted 5, I multiplied by 2, I stretched it, and then I shifted it down. And that's how you get that blue function. So again, if you like our videos and you want to see more free content, please consider liking, subscribing, and sharing. Thank you.